Okay, home plate for tonight is page 394, odds only. However, I do want you to graph those, even though the instructions on that page does not indicate to graph. But who's asking you to graph? Me. So please, pretty please, with a cherry on top. Okay. So we've had plenty of practice already with solving quadratic equations algebraically. And yesterday I also left you some practice, extra practice. And of course some of you were like kind of hesitant on some of them. So you went ahead and went to the video to watch it. And then you're like, oh, I see. And so on and so forth. Okay? So I'm going to get started with the lesson, and if we have a little bit of time, I'll go over one of those problems from the home play at the end. But just FYI, BTW, tomorrow being Friday, and you owe me like plenty of home play, I'm going to pick up a packet tomorrow. Just giving you a heads up. All right? Boom. That just happened. Let's go. I don't know. I'm going to put my randomizer in my Moodle and say, which ones do I pick up? Oh, this one, this one, this one, and this one, or whatever. All right, our objective for today, I can solve and graph rational functions. I can solve and graph rational functions. But what are you worried about? I mean, you guys have been doing all your home play. Yep. You should always be ready. Let's go. Right, once again, I can solve and graph rational functions. On your, I'm going to interchange those terms in regards to the objective. Notice on your screen it says I can solve and graph rational equations. So interchanging one for the other. We don't need a Frere model. Rational functions, it's still an equation that contains at least one rational expression. Do we know what they look like? Yes. What they don't, and hashtag, yes? All right, steps, write these down, please. 3 basic steps. Number 1, identify the vertical and horizontal asymptotes. Once again, identify the vertical and the horizontal asymptotes. Step 2, build an input-output table. And step 3, graph the function. So by now, since we've been working on graphing since the beginning of the school year, the very first week we started just graphing 1 variable equations. The second week we started graphing 2 variable equations and functions, including systems. So by now we should be very familiar. And we already know how to do graphing using an input-output table. Is that correct? Yes, Mr. Q. So basically today's task for us is to understand what asymptotes are, number 1, and number 2, how to graph rational functions. Okay? So I'm going to break it down in a sense, like always, to kind of like snowball it to get there. Yeah? So everybody go like this. Bear with me. Yes? We're going to get funner by the minute. Bam. Let's go. All right. So 3 basic steps. They should be on your screen, right? I'm going to leave them there for right now. However, here goes a quick recap in regards to transformations. I said at the beginning, not of the school year, but when we started with the Algebra 2 content, pay attention to this part, I said, we need to be very, very specific and focused on transformations because that's going to be the foundation of the entire Algebra 2 course. I did say that, right? Quotations. And I said, we're going to continue doing that for different functions as we go along throughout the year. You're like, oh yeah. So, from there, I generalized the rule. Okay, at this time, write your utensils down, look up to the screen. Chance, you good? Yeah? All right, here we go. So I remember when we got to this point, I gave you guys the general rule that looked like this. And from there, I said there's 4 different transformations that happen within this. The ones that we've been using the most, though, are these. Look up. This one and this one. Tell your neighbor what each of those does to any function, Very good. K is either up or down, depending if it's positive or negative, and this one is side to side, once again, depending if it's up to the positive or negative value. Okay. However, the one that we haven't used that much are A and B. Now, what does the coefficient of A outside of the f of x do to the entire function? So watch. If I was to give you the function, which is a parabola, look what this does. What is that called? A stretch vertically. What is the second thing it does? It compresses vertically. Either makes it stretched or itty-bitty compressed. Once again, vertically. Vertical. Well, in that case, B does what? Stretch horizontal or compress also horizontally to make it into a little bitty stretched parabola. You guys remember that now? Okay, this is horizontal. It's cute, but why are you going over these again? It's cool, because now it's going to look different with a rational. However, since we've been practicing these and we know what each thing does, even though it looks a little bit different, we still know what each piece does. Pagadori never let us know what each piece does of this new one. Once again. All right. Carlo, what does K do? Up or down. H, side to side. A, stretches or compresses vertically. And this one, stretches or compresses horizontally. All right. It's still the same thing, but the only thing, the setup looks a little bit different because now we are in rationals. Okay? So, for today's lesson, for rational functions, H and K are going to serve a second purpose. Not only to move, but it's going to serve a second purpose, and I'll show you that in a little bit. So, according to the steps I gave you guys, the first step is identifying asymptotes. So here you go. What are asymptotes? According to the definition given, they are a line that a graph set gets closer to as the absolute value of the variable increases. That's too wordy and that's kind of like confusing. Mr. Q's words. In other words, it's an invisible line that a graph will get close to but will never touch. Is that a little bit better? Kind of like, let's see, who's seen Star Wars already? Yeah, okay. So imagine I'm a Jedi Master, Q, and then Damien wanted to get close to me, and I went like this. And I used the Force. I used the Force. Can he get close to me? No, the Force is right there. That's what we call an asymptote. An asymptote is something invisible that no one can touch. That's why whenever we graph a function, and if there's an asymptote, we cannot touch that invisible line. Does that make sense? So, asymptotes, there's three kinds. The first one is a vertical, the second one is a horizontal, and the third one is known as a diagonal, a slant, or an oblique asymptote. Today we're not going to look at slanted or diagonal or oblique. We're only going to look at these two, vertical and horizontal. Now, vertical asymptote, obviously, if it's an invisible line, it should be like this. Can you guys see it? No, because it's invisible, right? So anyways, but the vertical line should look something like this. A horizontal line should look something like this. So far, so good? All right. All right, Mr. Q, I kind of get it, but I need to see it with what we're going to do today. All right, so here, let me show you. In a general rule, the H from now on will be our what? Vertical asymptote, which means, tell you never what K will be. That is correct. That would be our horizontal asymptote. All right? So with that said, let me show you now with an equation. Look up. I'm going to leave this up here. Pay attention, please. I'm going to start with example super cube. Look up. I'm going to start with my vertical asymptote. And from now on, I'm going to label that x equals. My horizontal asymptote, I'm going to label that y equals. So by looking at this function, look at it. Does this look kind of like this? Yes. Let's see. What do we have in place? Do we have a 1? Yes. Do we have the bar? Yes. Do we have a 1 over b? No. Do we have a in function? No. But do we have an x and a minus? Yes. So tell your neighbor the vertical asymptote. That is correct. It's 1. All right. With that same, tell your neighbor the horizontal asymptote. 2. That is correct. All right. Because it makes sense just by looking at that. Is that correct? Now, how does that look on our graph, Mr. Q? Let me show you. Focus, please. X equals 1 is right here. And if it's a vertical, there must be an invisible vertical line going through there. And how are we going to indicate that it's invisible? Like this, making a dotted line all the way through. Let me show you the horizontal. What is y? Y equals 2. There it is. There must be a horizontal line going through that point, and there it is. These are known as asymptotes. Now, what does that mean, Mr. Q? What that means is that once we get into the graphing portion, right now we're still not there. Once we get to the graphing portion, our graph cannot touch those two lines. Why? Because they are invisible asymptotes. Kind of like the force. Are we there? All right. So, that was an easy one because it's straightforward from there, yeah? Let me show you another one. That is what we call a parent function. This is the original rational function. It doesn't have any transformations or anything. It's just a regular rational equation, 1 over x. However, it does have asymptotes. Vertical asymptote. Horizontal asymptote. By looking at it, talk it over to your neighbor. Try to match it and let them know what the vertical one is and what the horizontal one is. Let's see. Leo, what's our vertical asymptote? X equals what? I'm sorry? Okay, this one was 1, yes, because it's got a number there. What is the vertical asymptote of this? 0 is correct. Hands if you got that. All right. Pass someone. Carlo, horizontal asymptote. 0. Why 0? Because we don't have a constant right here. That is correct. What does that look like, Mr. Q? Well, here's y0, and if it's a horizontal, then that means it's going straight through that point. Let me show you the vertical one. It's right here, and let me show you that. All right. Any questions up to right there? Piece of cake? All right. Yes. That's what we're going to get to. Right now, I just want to make sure we understand asymptotes and where they're found. Look at this example. Don't say it out loud. Now pay attention. Let me show you. The obvious one is the horizontal asymptote, which is y equals 5. That's the obvious one, right? But who notices that the vertical looks a little bit different? Yeah. Let me show you the vertical asymptote. Vertical asymptote is x equals 1.5. Tell your neighbor how we got that. How did we get that? All right. Now, let's see if some of you already identified it, some of you haven't. Let me show you. Look up. Who saw that the vertical asymptote is basically the excluded value? How do we find excluded value? The denominator equal to x minus 1 equal to 0 plus 1 plus 1, x equals 1. Let me show you this one. What is the denominator? X. So if we set it equal to 0, there it is. How about this one? What do? 2x minus 3 equal to 0 plus 3 plus 3. 2x equals 3. Divide by 2. X equals 1.5. How does that look like on our graph? 1.5 is right here. And 5 is up here. And that's how we identify asymptotes. Show me a famous algorithm you are identifying asymptotes. Okay. So, let's see how you do. Copy these. I want you to do example, and not on the graph paper. Do it on paper first right now. We still haven't gotten to the graphing part. I want you to do example 1A and B. Let's see how you do. Copy that and go. You got 45 seconds. So, let's recap on functions. Here we go. Look up, please. Write your utensils down. Oh, my goodness. Here we go. When we got to functions, I remember towards the end, I gave like an overview of what the functions look like in a graph form. And I said, y equals x, or y equals 3x plus 2, or y equals x whatever at the end. It's a straight line. Yes? From there we went to y equals x squared, and what does that look like? A parabola. From there we went to y equals x cubed. What does that look like? A little wiggle, like so. From there we went to y equals absolute value of x. What does that look like? A v. All right? Now, if all of those were graphed on a parabola, let's say this is my x-axis. Look what happens when this has a negative in front of it. What does it do? Upside down, or it flips according to the x-axis, and it should look something like this. Look at this one. If this is the x-axis, what happens if I put a negative here? It should be upside down according to the x-axis, and that happens to all of them. What happens to this one? Oh. What happens to this one? And so on and so forth. And that's obvious for all functions. Are we there so far? All right. Today's graph doesn't look anything like those. It has a little bit of all of them. So that's why I wanted to be specific when I introduced it. So write your pencil down, pay attention. Oh my goodness. F of x equals 1 over x is our parent function of our rational equation or functions. Here's my coordinate plane. This rational function, which is our parent function, will always, and repeat that again, will always look like this. Always. 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 All right? So whenever you see f of x equals 1 over x, guess what? That's what it looks like. Today I'm going to show you how to get the points, but that's what it looks like. I want you guys to look at it, be like, oh, students, rational functions, functions, students. Is that clear? Okay. So, if I was to ask you, graph this one, so right away, what are you going to do? It has to look something like that. Yes? However, look up. What would happen if it had a negative? Tell your neighbor, what would happen if it had a negative? It would reflect about what? About the x-axis. So this one will reflect down here, and this one will reflect up here. Fairly simple? Yes, Mr. Cube. All right, good. All right, let's move on. Let's crank it up a notch, yes? All right, on your big graph paper, copy this one on the top left. Example number 2, it reads, graph the function and identify the domain and range, f of x equals 1 over x. On the graph paper that your gopher went to get for you. F of x equals 1 over x. So right now, what we're going to do is what the home play is asking you to do. I'm asking you to graph. That's what we're going to do. Ready? Here it goes. What is step 1? I left it on the screen. What does it say? Identify the vertical and horizontal asymptotes. So I'm going to use, what's that? Yeah, the asymptotes that we just found. All right. So I used, was it red for the vertical or blue? Okay, so let's do vertical asymptote. X equals. So by looking at it, is there anything next to the x? No, so my asymptote is 0. So let's do that. X is here. So there's a straight line going through 0, like so. All right, that's invisible. There it is. Next, our horizontal asymptote. Y equals 2. Is there a constant here? No, so therefore it's also 0. So here's y0. If it's y0, that means there's a straight line going through that point, and it's invisible. Okay, there it is. All right. How we doing? All right, read us step 2, please. Lene, step 2. Build an input-output table. Here we go. X, f of x. All right, so let me show you, look up really quick. The x values, we usually use what? -2, -1, 0, 1, and 2. Is that correct? But for the purpose of this, look up. I want you to look for the vertical asymptote, and I want you to pick 3 x values to the left and 3 x values to the right of that asymptote. So watch. What would be the immediate one to the left? -1, -2, and -3. How about to the right? 1, 2, and 3. Can we use 0? Tell you never why not. It's an excluded value. It's an asymptote. So I'm going to do -3, -2, -1, not 0. I'm going to go to 1, 2, 3. Kenzie, focus. All right. So I'm going to start with green. Yes? Here we go. I'm going to circle the -3 with green because that's what I'm going to substitute in here. Yes? So instead of x, what goes there? 1 over -3. And what does that give us? -1/3. So what is the next value? 1 over -2, which is -1/2. What is the next one? 1 over -1. What is 1 over -1? -1. All right, let's plot those. Yes? Here we go. I'm going to zoom in. Let's see. I got -3 and -1/3. -3, -1/3 is about right there. The next one is -2, -1/2. The next one is -1, -1. What do you guys notice? It's starting to curve. Do you guys see it? All right. Look up. Just to be exact, what would I need to substitute into the function to get a point somewhere here? Negative. Damn, that is correct. -1/2. Did you guys see that? So, if I was to substitute -1/2, look up. I'm just going to write it right here. -1/2. That gives me, check this out, -2. And we'll talk about that in a little bit. So let's just put negative half goes to negative 2 right there. And now that it looks like a curve, then we sketch our function. Get close to the asymptote, but don't touch it. There you go. Kind of like MC Hammer, right? Don't touch this. No? Never mind. All right. All right, so we got that side. Now we need to do the other one. So let me switch to black. Here we go. So I'm going to substitute positive 1 into our function here. So we get what? 1 over 1. What is 1 over 1? 1. Very good. Next, I'm going to substitute what? 2, and that gives me 1 over 2. And then the last one is 3, and that is what? 1 over 3. Let's plot that. 1, 1. 1, 1 is right there. 2 and 1/2. 3 and 1/3. And by the way, if I wanted to get close right here, what did I substitute? Half. 1/2 gives me positive 2. And we'll talk about it right now. Positive 2 right there. All right, let's graph our function. There it is. How are we doing? Yes? All right. However, they want us to identify the domain and range. Domain. Okay, I'm going to write it in, you guys want intervals, set notation? Set notation? The domain for the function, what do you guys notice if it has arrow here, that it continues going to negative infinity? Is that correct? And over here it continues going to positive infinity? So which is the only value that we don't use? 0. So our domain is all x values such that, what else can we write? That includes all x values, right? What's another way of saying it? So that it kind of like all real numbers, comma, but x what? X what? Not equal to, bam, Daniel, let's go for Presidente. Not equal to what? 0, that is correct. Does that make sense? Let's go to the range. F of x such that, look at it, if it keeps going this way, it's going to go to the negative infinity of the f of x, positive infinity of f of x. Now, Yelly, finish it off. F of x what? Oh, Nayeli, deep voice. Yeah, all real numbers. What else? F of x cannot equal to 0. All right, show me your favorite welcome you are up to right there. Yeah, so what is the challenging part? The asymptotes and just computing the points, is that correct? All right, let's do another one. Copy this one. Example 2q. Y equals 1 over x minus 2 plus, x minus 1 plus 2. Once again, example 2q. Y equals 1 over x minus 1 plus 2. Okay, what's our step 1? Identify what? All right, so vertical asymptote. Tell your neighbor the vertical asymptote, please. X equals 1. That is correct. Horizontal asymptote. Lene, y equals 2. All right, so let's graph those. Y2 is right here. Wait, where am I using green? Wasn't it red? No, I'm going to change it. Be nice. All right, here we go. 2 is right there. So I go straight through there. And my X1 is right here. There it is. All right. Step 2, build an input-output table. Here we go. X, f of x. But wait a minute. Didn't the x asymptote move now a little bit to the right? And I said to pick 3 numbers from the left, 3 numbers from the right. So what 3 numbers am I going to use now? -2, -1, and 0. That is correct. So I'm going to do -2, -1, and 0. Okay. Can I use 1? No. Tell your neighbor why not. It's the asymptote, or the excluded value. So that means if I go 3 to the right, what numbers am I going to use? 2, 3, and 4. 2, 3, and 4. Okay. So with green, I'm going to substitute values in here to get my first values. Here we go, -2. So if I substitute in here, I get what? 1 over -2 minus 1, and then at the end, plus 2. So what is -2 and -1? So that gives me what? -1/3. You guys see what I'm doing here? I'm substituting these in here for x. So what is -1/3 plus 2? 1.6. I'll just leave it at 6 for right now. All right, let's go to the next one. -1. I'm going to substitute it in here. So it's 1 over -1 minus 1 plus 2. What is -1 minus 1? -2. So it's -1/2 plus 2. What does that give? 1.5. Very good. Some of you are like, Mr. Q, I get confused with complex numbers. 0. Substitute 0 in here. That leaves me with -1. 1 over -1 is -1 plus 2, 1. Okay, let's plot those really quick. Let's see. -2, 1.6 is about right there. -1 is 1.5, which is right there. 0 is 1. You want to do a half, or do you know where the direction it goes now? All right, good. Here we go. Get close, but don't touch the asymptotes. There it is. How are we doing? Okay, let's do the other piece. This piece. Here we go. I'm going to use blue for this one. I'm going to substitute the 2 in here. 2. So I end up with 1 over 2 minus 1 plus 2. What is 2 minus 1? 1 over 1 plus 2. That gives me 3. That goes right there. Next, I'm going to substitute 3 now. 1 over 3 minus 1 plus 2. What is 3 minus 1? So it's 1/2 plus 2. So that is 2.5. The last one, we got 1 over 4 minus 1 plus 2. What is 4 minus 1? 1/3 plus 2, 2.3. All right, plot that. 2, 3, 2, 3. 3 and 2.5, 3, 2.5. And 4, 2.3, 4, 2.3, which is right there. So if he was to graph this, it would go something like that. Gentlemen, if you're welcome to your art with these so far? Yeah. Now, let me throw a little wrench in here. Look up. Look up, guys. Look up, you're going to miss it. What if I gave you this function and you already worked it out, and I said, oh, you know what, guys? Let's do this. Talk it over to your neighbor, let them know what's going to happen to all that. All right, who went last? Who's helping me out? Carlos. Pass it to Alexa. Alexa, what's going to happen to the whole thing? They reflect over the x-axis. However, look up. Since it's not on the x-axis, they're going to reflect about the what? The horizontal asymptote. So that means instead of being here, where's it going to be? Right there. How about this one? It's going to be right there. Yes? One more? Okay, here we go. Copy this one. You're going to do this one by yourself. I want you to graph it. Use any graph coordinate plane that you have. You have plenty of them. I'll give you some time. Example 2 super Q. It reads, graph the function and identify the domain and range. Y equals 1 over x plus 2. And then at the end, minus 3. Copy that and go. I'll give you a head start. All right, for those of you that still are a little bit confused, if we look at our general rule for functions, this needed to be a negative, is that correct? Then we use 2, but since it's a positive, what is the opposite? Negative 2. Or set it equal to 0 and solve for x. Now the question is, what values do I use for my table, Mr. Q? Well, let's see. Where's my vertical asymptote? At negative 2, which is right there. There's my invisible line. So that means I need 3 values from the left side and 3 values for the right for my x. What are my 3 values from the left? Negative 3, negative 4, and negative 5. Why can't I use negative 2, Mr. Q? Because it's one of the excluded values. What values do I use from the right of that asymptote? Negative 1, 0, and 1. Yes? And my horizontal asymptote is at negative 3. That means it's going to be like so. So, can you picture our graph where it's going to be? Yes, it's going to be right here and here. Remember, it's the same graph that I gave you at the beginning. The only thing, it moves according to the asymptotes. All right? So, let me zoom out. Our table. We got x, f of x. Let's see, Clarissa, what x values did you use? Negative 5, negative 4, negative 3. Hands if you wrote those down. Yes. How about for the positives? That. Or, I'm saying, what are the other 3 that you would use? Negative 1, 0, and 1. Hands if you got that. That is correct. So let's see. If I substitute this one, negative 5 in here, what is negative 5 plus 2? Negative 3. That leaves me with negative 1/3 minus 3. That's negative 3.3. And so on and so forth. Yeah, the domain, remember, it's going to be all real values except for the x asymptote, and same thing for the y. Okay? All right, let's see how you do tonight. Page 394 odds only, but I do want you to graph, even though it doesn't say it there. Good one, guys. It's your home play. See you guys tomorrow. Bye.